In Lesson 4, we're going to answer the questions, how do I find the perimeter and area of any triangle, and how do I find the missing measurements of any triangle? That means we're going to look at other triangles besides right triangles. We're going to see obtuse and acute. Here's an example of an acute triangle. You can see it's acute because you've got 3 acute angles inside that triangle. Well, take a look at what we have over here. Here is our original acute triangle, triangle ACD. If we were to double it, we would now have another triangle attached that would create a parallelogram. That means that this acute triangle is actually half of this parallelogram. That's our related parallelogram. Just like we had related rectangles with our right triangles, we have related parallelograms with some of our other triangles. Here's another example, this time with an obtuse triangle. Here, if we were to double this triangle, here's the original, triangle EFG is right here. If I were to double it, I would now have another triangle attached and maybe flipped around, and there is my related parallelogram. So this triangle, this obtuse triangle, is actually half of the related parallelogram over here. So look at workbook page 57. How does the area of the shaded triangle compare to the area of the parallelogram? Well, remember, the area of the triangle is half the area of the parallelogram. What measurements do you need to know to find the area of any triangle? Well, remember, if you want to know the area of a parallelogram, you had to do base times height. Well, the same thing is going to go for acute and obtuse triangles. You still need to know base times height. And actually, that's the same thing for right triangles as well. So, write a formula for the area of any triangle. Well, to find the area of a parallelogram, you have to do base times height. But if we're talking about half of a parallelogram, we're talking about half base times height. Also known as base times height divided by 2. Take a look at your formula sheet. Did you notice the triangle that's on there is not even a right triangle? That's the same triangle that you looked at in lesson 2 when we were talking about right triangles. The formula is still the same no matter what triangle, whether it's acute, right, or obtuse. You need to do base times height, and of course you're doing half of that or dividing it by 2 to find the area of a triangle. So let's take a look at 20 and 21 on workbook page 57. The parallelogram and the shaded triangle shown here both have a base of 4 and a height of 3. What is the area of the parallelogram? So I know I have to do base times height. That means the area of the parallelogram is going to be 12 centimeters squared, 4 times 3. Therefore, what's the area of the shaded triangle? Well, that's going to be half the area of the parallelogram, so half of 12. The area would be 6 squared centimeters. Looking at 22 through 24, let's talk about the height of a triangle. The height of a triangle is a line segment drawn from a vertex perpendicular to the base. There's that word again. Don't forget, base and height are always perpendicular. Sometimes the base has to be extended to draw the height. Just like with parallelograms, sometimes we had to draw an extension from the base to figure out how tall the parallelogram is. Same thing for triangles, particularly obtuse triangles. So let's see, which line segment shows the height of triangle ADC? Well, I'm looking at BD here, and yes, BD is perpendicular to the base. However, look at where it's stopping. That doesn't really show me how tall or the height of that obtuse triangle. So I don't think BD is going to be the answer. Let's look at AE. AE is also perpendicular to the base. It's kind of, you can see the extension right here. But it also does show you how tall that triangle really is, because it goes all the way up to point A. So I would say line segment AE is going to be the height of triangle ADC. And which line segment shows the height of triangle XYZ? Well, XYZ is a right triangle. It's really not too difficult to pick out the height of a right triangle. Here it is, XZ. That shows you how tall the triangle is, and it's perpendicular to the base, which is ZY. So XZ is the line segment that shows the height. How are the heights of acute, obtuse, and right triangles alike and different? Well, all heights are perpendicular to the base, meaning it doesn't matter if it's a right triangle, an acute triangle, an obtuse triangle, your height is always going to be perpendicular to the base. Not all heights are in the triangle. Some may be outside the triangle, like in obtuse triangles. So that could be a difference. This is an example up here of an obtuse triangle where the height is outside the triangle itself. Alright, what is the missing base? A couple ways to go about this, if you remember. We know the formula for finding the area of a triangle is 1/2 base times height. Well, we already have our area. Our area is 64. The 1/2 is staying the same. We don't have the base, so I'm just going to leave a B there for base. I do know the height, and be careful, because remember, height and base need to be perpendicular. 8 is going to be the height here. I'm not going to use the 12, I'm not going to use the 10, they don't show the height. So let's see, 64 is equal to 1/2 times the base times 8. Well, I don't know what B is, but I can still do some of this multiplication, even if it's in a different order. It's all multiplication, it doesn't matter the order. So I might do 1/2 times 8 first. 1/2 times 8 is going to give me 4, right? Because basically you're talking about 8 over 2, which simplifies to 4. Or think of it this way, half of 8. So now I have 64 still remains as the area, and B is still missing, but I took care of this 1/2 times 8 part, and I've got 4 there instead. So now I have to think, okay, what number times 4 gives me 64? Or go backwards. Take your 64 and divide it by 4, and you'll get your missing base. In this case, 16 centimeters is the missing base. Now, if that seems a little confusing, if you don't like that method, just like the right triangles, there's another way to go about this. In lesson 2, you saw that you could double the area of the right triangle and turn it into a rectangle, right? The related rectangle. You can do that here. What if you had another triangle just like the one above, and you put it together? Let's see if it lets me move it. There we go. You put it together to form the related parallelogram. Now let's solve it as if we're talking about a parallelogram and we're missing the base of the parallelogram. The formula for a parallelogram is still, let's see, base times height. We don't have to worry about the half anymore because we're talking about a parallelogram. Well, the area here is no longer 64. 64 was the area of just the triangle. Well, now we've got 2 triangles. That means we have to double the area. We now have an area of 128. Again, our base is still missing. Our height never changed. It's still 8. So we have to think to ourselves, what number times 8 is going to give me 128? Or go backwards. Do 128 divided by the height that you have, which is 8, and you're still going to get 16 centimeters. Okay, our takeaways. First, a vertex. I don't know if I talked too much about that, but a vertex is a point common to two sides of an angle. A related parallelogram. Well, a parallelogram with the same base and height as its related triangle. And finally, to find the missing base or height of an acute or obtuse triangle, double the area to create the related parallelogram, and then divide by the given base or height, whichever one they give you.